Okay, so in the agenda, we'll discuss a couple of things, looking at tracebacks, staring actually at them. It's very important to stare at tracebacks, not just look. And use educated guessing to figure out what's going on. Use print statements, and they're not bad, not at all. And then we'll spend most of our time doing interactive debugging with the Python debugger and introspection. And we'll also introduce some Python tools. If you already know all of these 5 commands here, until, jump, debug, actually know if you know what it does and how to use it, Pdb Plus Plus and Sentry, you will probably not learn anything really new today, and you can just move along to whatever other track is more interesting to you, maybe. So we have, as I said, we're going to have 3 different example applications. The first one is going to be a really small script because it's simple, it doesn't require installation, and just easy to set up. The second one is Flask because it's a web conference, and Flask is a very, very prominent web framework. And the third one is going to be Plone. It's an open source content management. It's really huge and complex, and I love it. And the point why you use these different tools is that the various tools that you have at your disposal when debugging make more or less sense in different environments. So if you have a really complex and huge application with a giant code base like Plone, it makes more sense to use some tools that you probably wouldn't use if you're debugging a simple script. As I said, we're going to use Python 3, and we'll start up with installation, and you'll just install create a folder, go to your terminal. I'll do the same, so you see what I'm doing. Actually, I have to close this. So here's my terminal. I'll try to share these two. So I have a folder called debugging. There are 3. It has 3 subfolders. One is Flask, Plone, and Script, and we'll start with the Flask one. So you already got this installed when we come to that. So you do git clone this here. I'm gonna post this URL in the how's it called, Slack, and also the next one. Oops. Yes, anyone had a question? Okay, maybe misheard that. So, okay, let me, when I do git clone, the small Flask application, it creates a folder, Flask. In here you have I have a bit more, but you only have, okay, I'll try to do exactly as you, so it doesn't look confusing. And I'm gonna call that Flask 2 for me because I already have the other one. 2. And in there now I have a requirements.txt and a demo py and the README. And you can just go to the README in here to follow these instructions, or you just can follow along. I'll do that, follow these instructions on GitHub. It creates a minimal Flask application. You can create a virtual environment. You can use different tools. I always use pyenv for that, but this is a very basic way to create a virtual environment with venv, the built-in virtual environment tool of Python, and enable that with source bin activate. So now I'm in a virtual environment, it's already running. And now I can do pip install -r requirements, and it'll install Flask. And there's a typo, requirements. There's a typo in requirements, excellent. Oh, the .txt is missing, sorry. You need to add the .txt to pip install requirements. And that's it. We're gone, we're done. If you're running Flask, you just copy this command and the application is already running. So moving on, actually, because that was really quick. And you can do that even in a break if you're not finished yet. But this one, you should definitely do this one before continuing, because installing clone takes a while. So it would be good if this command, especially this one here, is running while I'm continuing to thank you. While I continue to talk. So I'll git clone into clone. Here's my clone folder. It creates a empty folder, create a virtual environment inside that empty module, that empty folder, and then use enable that. I missed the source bin activate here, obviously, but you can. Why is this out? Because I'm not using the git one version. Here, source bin activate. Unless you want to use pyenv, which I'm doing here actually. Hang on. My old virtual env was still active. So here, this is pyenv. When I enter this folder, because I have a local pyenv virtual env running in this folder, it tells me debugging clone is my virtual env. It's a nice tool. You should get to know that. Pip install our requirements again, this time with a .txt, which is good, and then just run bin build out or build out, depends on how you start your virtual env. And this will take a while. Just go with it, and we'll continue, and we'll start clone when we get to that. So these two links are in the chat, and we should be good to go. If you have questions, or if you asked a question and I didn't answer that, please ideally use the Slack, because I can't open the Slido at the moment while the Zoom is running. So, okay. So the most, how do you start that? Yeah, let's do that. So the most basic form of debugging is actually staring at the code, as I said, and finding out how it works and why it doesn't work like you intended it to. The question is, why is that? The reason that this is the most important and basic form of debugging is that code is meant to be read, not written. And the biggest part of programming is actually reading code and not writing it, unless you're a genius or you're sloppy, and you shouldn't be either if you're a human. So you should try to prevent errors. That's the most important. You should try to prevent the necessity for debugging. So you need to try to write as readable code as possible. This is really the most important lesson you should take away from this tutorial. Try to write the most readable code that you can imagine. And the easier code is to read, the easier it is to understand, and the easier is to find errors and to prevent errors. So don't try to be smart and fancy. Try to be understandable, intelligible. So you should reduce distractions definitely by using PEP 8 and other code style guidelines. Use black or and code linters. We always use black in our projects. Add doc strings when your code is not self-explaining. And if you need to write doc strings, there is a lot of Python developers who are very adamant about that. If your code requires you to write doc strings, your code is already broken, because it should be self-explaining. I can't follow this logic, because I'm not smart enough to have all my code be as understandable as possible, but so write doc strings. That's a good thing. And imagine whenever you write code as if you were writing for yourself 10 years from now. I mean in the past, not in the future. Not for the smarter future you, but for the dumber, younger, less experienced you that you were in the past. And try to be to think about the people who are coming after you that have to deal with your code. That's really the most important thing. Also, make sure, yes.
Someone's got an error in their poem build out that you may want to look at in the Slack.
Yeah, you obviously have either, if you have a proxy server, yes, it doesn't work. And also if you have a very old SSL thingy, if your Python version is too old, it might have an old, that is weird. Well, it should work for this URL, but it's a different technology that's used for that. If it's failing, I'm sorry. I can't get into that error in detail. Maybe someone in the chat can help them anymore. It is usually, yeah, something with your local SSL libSSL, whatever this thing. I know what you know what I mean. So the last thing is. Make sure that your programs work as you work on them. So develop incrementally, write small parts of code, make sure that they work as you intend them to. Code a little, run a little, and then fix a little. If they don't, it doesn't run. Ideally, do test-driven development, but I actually know only few people who can do that and who actually do that. So yeah. Wow, this is here. Should have used this one instead of the super weird keynote presentation mode, where I can't see you. So when you did that and you written everything, followed all these advices, this advice, you have beautiful code, it's tested, it's documented, and there's still a bug. You need to find out what's going on. There are a couple of different bugs, and they're hard to distinguish sometimes, and it's really important that you try to find which kind it is. The most obvious one is obviously the traceback that you get, and that's the first one we'll get is a traceback. So we'll get a obvious error now, and we'll create a simple example script. It's this one here. I'll paste that in the Slack. I hope I can do that. I guess I can. And now, see. No, this is text. Why didn't this? No, this should. Oh, it looks like code, but it doesn't. It's not. Hang on. How do you do that? No. Okay, now we got the code. So this is the first traceback you will get. Create a folder called script. Make their script. I'm going to cd into script, and in there create a file called debugging.py. Debugging.py. I'm going to open my editor in here. Actually, I already have it open. So here's all my folders. I'm going to remove this irritating Flask 2 thingy because I'm not going to use that. And I'm also going to remove this out. So here's my script. You can create a virtual env for that, but you don't have to, because you can just use your system Python if you have a system Python. And this is the code that you should use for that. Paste it from the Slack channel. I'll also upload it. I'm doing this as I go because this also as it's here as a example how you quickly get stuff across to other people, how to communicate. I'll just create a gist with this debugging.py. Please, 4 spaces. Here is my file. Create, hopefully, a public gist. Bam, here it is. So here's the code. So now, while you're copying, half of you is copying the code, the other half already has it. Before we run it, stare at it. I actually made a mistake. There's something missing here. And there's, oh God, I already fixed a couple of things. Hang on. I'll update my gist. This also works. I hope. Yes. This will work. Update public gist. Yay. So now stare at the code, and someone please tell me what's going wrong here, because there's a couple of things that are going wrong. Just shout or type or say something. Anyone? Different types in list, that's absolutely normal. That's not a bug. I'll increase the font size. But it's definitely a problem. It's just not a bug. It's a problem because you always have to deal with different data coming in from various sources, especially if you allow your users to input data in your application. You will end up with the most atrocious data types. Okay, anyone else? Who spots the obvious error in line 1? Missing value in index 8, exactly. But it's actually not a missing value, but it's absolutely right. It is a syntax error. This is not valid Python. If I start my, if I start this now, which I'm gonna do, Python debugging, it'll, what? Yeah, would be helpful to not nonsense. Hang on, I didn't save again. Invalid syntax. And it also told me where my invalid syntax is because I added a second comma here that doesn't belong or where a value is missing. So here, remove this comma. Okay, now we fixed one error in this code. Who found something else? Who has more things to complain about this code? There's a lot to complain, actually. Okay, no one? Or am I missing comments? Okay, so what's wrong with this line here? This is not used anywhere. It's useless. It makes no sense to have an import in a file that's useless. It is not a syntax error. It is not a bug per se. But if you import something like requests, for example, here, and you're not using it, and you haven't installed it, it'll throw an error because you can't import requests. But other people who may have requests installed in their system Python or in the Python they're using for this script will not get this error. So it's a really terrible idea to import stuff that you don't use, and you should absolutely never do that, and clean up your imports. Okay, this is another obvious thing. What else is obvious? Maybe let's run that and see what's happening. Okay, Python debugging py, and here we got our first traceback. So we see there's an output of a 14 and it prints skipping 700, and then there's a traceback, and I'll go to the presentation part where we see that traceback again. So here's my output 14 skipping 700, and then it does boom, and we get this traceback thingy here. And the statement here is type error, argument of type int is not iterable. So you can ponder on that while I cover, and you'll present me with a solution while I cover the other types of bugs that are there. Yes, exactly. Very good, Sebastian. So you'll have to tell me afterwards, how do we make a integer iterable? But first, okay, so this is an obvious bug because we get a traceback, and the traceback actually tells us what's wrong with the code. There's something very important there that I'm going to try to reiterate later. But there are more. There are hidden bugs. For example, you get an unexpected result. Because the data that's coming in is of the wrong type and it evaluates as true when you think it's actually false. For example, if you say, let's say this here, if you have a Boolean and you say true, it is true. And if you say Boolean false, it is obviously false. But if you say Boolean string false, it is true. So this is a perfect example of a hidden type of bug because the data you're getting is expecting it acts in an unexpected way. Because what happens, for example, when you add a query string to a URL, like whatever parameter equals true or false, usually web frameworks turn these into a string. So whatever web framework you're using doesn't, if you say in your browser, say here, foo equals false, foo will be true because false is a string. So that's important. And if you do web development, this will happen to you a couple of times. There are more interesting ones. There are the elusive type of bugs. These are the bugs where the result varies under changing circumstances. A beautiful example was a test at a Plone sprint that I attended that checked for events in a calendar. And at night, we usually code at night with lots of whiskey and beer. On March 31st in 2013, at 2 a.m. in the morning, a test suddenly failed. So who can guess what happened at 2 a.m. on March 31st in 2013? Anyone? That was a good answer. You can also unmute your microphone and just shout out. Thank you, daylight savings, excellent. So daylight saving time switched and the test failed, and I spent hours trying to find the bug that was never there because only the test failed. Yeah, Dave, I agree with you. So there are more. There is the feature. Similar to the hidden one, because the string and the request, it's not a bug that falls if you hear that this is a string. It's intentionally that it's a string. But there are more evil features. One example is the, if you know Plone, there is an index called sortable title, and it has this beautiful, this is the code, and I'll let you stare at that for a second, and maybe you can tell me what is creating elusive, what's elusive about these bugs. No, that's not the elusive one. What's a feature? What's the feature here that creates bugs? It's not super readable because it supports Python 2 and Python 3. We haven't gotten around to remove all the compatibility code in Plone yet, but the modern versions only, the newest version only supports Python 3. So the problem here is this. So it sorts content by title, and if your title is longer than a certain length, so max sortable title is 40 here, Then it snips it after, at the end, it takes a part of the end. Can't really understand it. 13 characters from the end. It chops it into pieces, and it adds a ... in the middle, and just the text in between. So if you have a content object with the title meeting minutes for the board of directors of and off, after off, your date is there. There's date, and it's beautifully done, like 2021 minus month minus day in the beautiful sortable way. It's never going to sort in the right way because the title is already too long, and it's going to be sorted. It's going to be, yeah, not sorted with not sortable, because the date's never going to be part of the sortable title index. So that is evil, and it's a feature because it saves a couple of bits or bytes, yeah, and yeah, not bad, not good. Also, the next last type of bug is the masked bug. That is when there is an exception and you never get to see that because it's wrapped in a try except. For example, a lot of applications do that, but Plone also does that. When you index content, for example, a PDF or Word document, you throw it at the application and you do a full text index for that, and you're missing the appropriate indexers, or the file is maybe of the wrong type or stuff like that. These errors are often ignored because it would be super annoying to get all these tracebacks. And then you're wondering, why can't I find my content? And the reason is because the error that happens after the try is ignored in the except clause, and you never see that. So once you know there is a bug, there's a process, obviously. The most important and maybe really the hard one, we're not going to do too much with that, but reproducing bugs is really hard. I guess you all know these clients who say, it doesn't work for me. And then you have to send these emails, say, okay, which URL are you talking about? What browser are you using? Can you send me a screenshot? What's the error message that you see? So it's always hard to perfectly reproduce a bug. Today it's a bit more easy in our tutorial because my bugs are pre-prepared. Then you have to isolate and understand the bug. For example, here the bug being within the try except, or so that you see where the bug is actually happening. And then you can, when you get to there, you can also understand the why. And the why is usually leading you to the answer of how to fix or eliminate the bug or work around the bug. Oftentimes you have to work around that. I'm going to skip
my talk on Thursday is going to be more about the process. And I'm glad to see I have the same 3 steps you do.
Excellent. Cool. Great. I'm going to skip the exceptions part. So let's go back to that traceback. So good. So the answer is wrap it in a iterator. Unlucky number. So how do we wrap a number in an iterator? Iter 7, make a list out of that, maybe, yeah, something like that. So, but look at the intention here. If we do that, make an iterator out of that. Let's just go with this and try it. It's a workshop. Int object is not iterable, so we can't do that. So we need to make that actually, don't make it implicitly, but explicitly into a list. Yeah, but now it doesn't work at all because we want to skip all these 7s because they're, for some reason, super unlucky numbers. Are we testing for this? Yes, 7 is the unlucky number. No, if 7 is in, so that's the point. It's in. So someone wrote this code, and he said, if there's a 7 in my number, in my value, I don't want that. It's not going to be okay. So how do you turn 700, for example, here 700 or 7 or 4 into something that is iterable? Maybe the problem is something else, and we'll just do this for a chance. Maybe it's with the string number thingies, but I can tell you it is not, because when I run it like this, I get a different error. Argument of type int is not iterable because this thing is not iterable. So, nothing to do with this. What's the type here? Okay, we don't know. Let's pretend we don't know. The point is, we want to debug this. We don't want an educated guess. It would be good to just fix that straight away. We want to find out how to fix that. But first, and let's look at some more tracebacks. We'll see a couple of more of them. And some of them are really self-explaining. This, it seems, is not super self-explaining, to at least not to all of you. Are we testing for the 7 in the number being only 7? No. Yeah. Thank you. Yeah, string 7 in value, but the value is integer. So much can go wrong. So let's look at this traceback here. So these are a couple of tracebacks from a older application that we're older website that we're relaunching, and there is an import thing that's going on here that is importing a lot of content and into the new site. And what's going on here? Who can tell me what's wrong with this application? Where did it fail? Oh, I sometimes there's a lag in the chat, because if you're only listening on Loudswarm, there is a lag. That's when I ask a question and you type the answer and I don't see the answer, is because there's a couple of minutes of difference. So it would be best if you're joining the Zoom if you want to follow that. Nobody? Okay, it says here, there's the answer is here. Please tell me, someone, just read that, someone, to me. It's a memory error. Ah, cool, good. Excellent, Sean. Yes, buffer got too big and memory ran out. Because my MacBook Air here has plenty memory, it all worked fine, but once I deployed that on a server, it was a virtual server, and the memory just was gone. There's no 32 Gs on my virtual server that was running this import. So here, when I'm reading a JSON file, this item is a file object. It's actually a path object. It uses the pathlib, which is a great tool. Here, pathlib, and it has this beautiful method read text that does implicit decoding for the content to text. That is like old and previously Unicode, and this file is like really, really huge, so it ran out of memory. Good. Similar, and you will see this a lot in your applications probably, especially if you did Python 2 development in earlier days. We had to decode stuff back and forth all the time, from bytes to text and text to bytes, and all the time it failed. And sometimes you get a Unicode decode error or whatever. A couple of different errors were possible here. And this time, non-type object has no attribute decode. So what's going wrong here? Can someone guess what's wrong here?
It's already decoded, so you can't decode it again.
Nope. Bam. I love it when people do the same mistakes as I do all the time. Because we have these decode errors all the time, we're so focused on these types of problems that we don't see the obvious.
Oh, it's none.
Yes, thank you. And that's the most important lesson about tracebacks is, let me scroll to that, do not jump to conclusions and take some time to actually read the traceback. And I can't tell you how often I did not follow my own advice. I spent hours and hours of my life and wasted time and money by just thinking, oh yeah, I know what this probably is. But there was Plone gives you error messages, for example. There's these beautiful error messages on top of the page, and it gives you tracebacks when you do development. And if you jump to conclusions instead of actually reading the error message or the traceback, you will mostly get it wrong. And like Chrissy and me usually got it wrong and said, oh, this Umsatzsteuer, this is a tax thingy, needs to be decoded to UTF-8, and it obviously failed. Yeah, no, the problem is it just was none. Get property USTID was none. And the interesting thing here is also it's a very common Python error. You do these. Let me. Foo is my dictionary. Let's say this is in my foo, and I do foo get. Hang on, and I do or this. When you do a fallback, I think when there is no bar, I always get an empty string, and that empty string can then safely be decoded still. But when bar is actually none, this fallback doesn't jump in. So foo get bar is not none or something like that. Then you can deal with these. So that's a very, very common issue also. Ryan, you were trying to say something, but your audio cut out. Type the question if it was a question. Otherwise, maybe you just had to answer your phone. Okay, so these are tracebacks, and the most important thing is really take your time to read through them and try to understand where the error happens and what's going on. And usually it just says so on your screen, and you should just focus your brain to get that information from the screen inside your gray matter, and then you understand. Usually, then the solution is obvious, but don't guesstimate. Okay, but for our script here, we still have no clue what's going wrong here. So we have a 7 and a value, and just it's whatever. It's an unlucky script, obviously. So we'll try to fix that by using a print statement. It's the most basic form of debugging after you looked at the traceback and couldn't figure out what's going wrong there. So just we'll add a print statement here, and I'll print the value just before the error happens, because it tells me that the traceback is really is full of information. It tells me in which file, in which number, in which module or method the code actually is failing. And the last one, most recent call last, is where the error happens, and the error happens in this line, return 7 in value. In the method is unlucky number. And so before this line is executed, I'll just add a print statement to print out my value. Let's see what happens. Okay. Is this helpful? It's totally not helpful, because it tells me my value is 7. And it's 14, and it's 700, and now it's 7. Yeah, I know that it's 7 because it says It says here that it's 7. So this doesn't help me. So very often, again, it has to do with types, why something is not working. So it's, in this case, the int is not iterable, or yeah, the int is not iterable. That's my issue. So if a type int is not iterable, what other types are there, and what can be used? What should be used here? Why is that double? That shouldn't be double. So okay, let's try to improve this print statement like this. We're using a f string here. F strings are the best invention ever. It's the same as doing a format with the values, but you can just write your Python code in here. So trying, let's make it trying value. So it prints the value, and it gives me the type of the value. Okay, let's run that now. Let's see what's going on there. There's trying 14, which it says it's a string. Trying 700, also a string. And it's trying 7, which is an integer. So everything else, when it worked, it was a string. So how do you convert an integer to a string? That is simple. Just wrap it into str. And now, let's see what's happening. Crap, it's not working again. So I can only concatenate string, not int, to string. So my solution was obviously wrong. Is that right? Yes or no? My solution was wrong. Anyone? What mistake did I make just now? Okay, since no one else is saying that, I'm saying it. I jumped to conclusions because I didn't read my traceback, because the traceback, thank you, is not in the line that I just fixed, but somewhere else. So it doesn't say my solution was wrong. It just tells me something else might be going wrong, because here is print skipping plus value. So it's trying to skip the value. It's logging or printing the information of what it's doing there. So, okay, there's more going on, and I can't understand what's going wrong here. And I'm at a loss at this point. I just pretend I'm at a loss, and we'll have to haul out the big guns and try to fix this script in a different way. I'm not going to go into logging too much, but you should use logging for you can use logging for this, but during development it's not really important. And in some cases, actually, print is better than logging, because, for example, when you write, when you have a bug in a test, and you have a complex test suite like Plone does, each test, just before the test itself run through thousands of lines of code, a log message would never show up on your screen, but a print statement will actually show up on your screen when you do a debugging of a test. So don't look down on the print statement. It is really, really useful. But for when your application is actually running, you should use the logs logging module. Okay, let's jump into the Python debug. Try to fix that with the Python debugger. So Pdb is built in Python. You don't have to install anything. It's just there. And it is instantiated with pdb.settrace, or if you're using a modern version, which you definitely should, with Breakpoint. Pdb settrace is still there, but Breakpoint is a nice wrapper for that. It's actually also semantically more correct, because we're not setting a trace. No, we're setting a breakpoint. It's like, it's bad wording here. It's a breakpoint that we're creating, and in JavaScript or in a visual debugger, we're doing the same. So let's go back to here where we added our print statement. and replace that with a breakpoint and start the application again. And oh God, I was too fast. Hang on. Again, good. So clear my screen. Good. So my script was running up to a certain point, and then it just stopped. And I see this output here. And the PDB, or the debugger, is the most important tool you're ever going to use in when you're doing Python development. And you should try to put all of these things in your muscle memory. Yeah. So the PDB just stopped here, and it's the first time you ever instantiated the Python debugger. So what do when you're lost? You ask for help. Obviously, you do that by yelling help. And the Python debugger has this helpful list of commands that are available to that. And you can say help list, for example, and it shows you what the command does. I'm going to through all the important commands and going to demonstrate them to you, and you can follow these. Let me do a show of hands. Who has this running now? So I want to find out how many people are actually following the code examples. They're not super exciting at the moment. We're going way deeper soon. Can you, I don't know, wave or say yup or something else in the Slack, or nope? Yeah, okay, at least 3 thumbs, 4 thumbs, excellent. Good. So I know which that I shouldn't try to overtake you speed-wise if you try to follow these commands. So I asked for help on the very most important command, which is list. And hang on, where's my browser? Here's my browser. So help ll, and this is the most important command. I'll go through the basic commands and show them to you. So list shows you the code that you're currently looking at. I hate the L because when you do it twice, it just stops, because when your file is very long, it goes in blocks of 10 lines each. So I always use LL, that's the long list, and it lists the source code for the current function, but only the current function. If you want to see something else, you can say L line 3 up to 20, and then you see these lines. That's very helpful. So list is very important, especially if you're trying to debug code that you don't have open in your editor, or if it's a longer method where you're walking through this method line by line and you're not sure where you are and you don't want to switch between your editor and the terminal back and forth all the time. So list or long list is the most important command here. Next is the second most important command, because it executes the next statement, n, and this return here. It even says what it returns, because we're in a return statement, and the value it puts out is false. It's nowhere displayed to the user, but when you're debugging, it's doing that, and it's here. I said next again, so now you're confused probably. I said next, which executed this line of code, and then it returned none. And where did I end up now? No longer here. Let's see where I am by using long list. Oh, now I'm here. How come? Because I was just in this small method, if is unlucky number, the return value was false, so it skipped everything in the if statement and went to the next line. So the lines of execution of code, obviously after this line is executed. This is why I'm here. And this is also why LL is so super important, because if your code jumps back and forth all the time, it's sometimes hard to find out where you are. And LL just very quickly shows you, here I am. Even shows me an arrow pointing at the line of code that is executed next. So when I say next, the print value is executed and value was 14. So let me stop this and go again. So these were already two commands, LL, and next, but there is way more, because this is a Python interactive. This is Python. This is not it's not a user interface where you can only have these couple of commands at your disposal. You can say bool false. You can execute any kind of Python that you want. You can, for example, find out that your false is actually true. And more importantly, and that's what you're going to do a lot, is you can find out if we didn't have this fix yet, we could, let me start this again, we could inspect value. Oops, value. So it's 14, okay. Next and next and next and so on and so on. Hang on. Value 7. Okay, I did a continue, which I'm coming to in a second. So now my value is something else. It's no longer the string 14, but it's a number 7. So I can say value, and it prints that, and I can say type value, and I can inspect that. I can interact with the running application. I can actually import stuff here. Import auth path, whatever. I can do all kinds of stuff. I can go ahead and delete my hard disk from here, from my PDB. I don't want to do that, because then I'm going to stop this. My browser will be deleted as well, so I shouldn't do that. But I can, because this is a full, it's not like nothing virtual about that. This is real Python. I can do everything here. So this is very important. Okay, we did next. I also did C already. Let's do this again. So my first iteration here is value is now 14. And I say, this is not the one I'm looking for, but I'm iterating over these through these values. So I'm just going to continue. Just ignore the PDB. Just go ahead. Bam. Oops. Sorry. Wrong. So here. Type C. And now it continues until the next instance, where the next traceback, because this method is called a second time with 700, and the breakpoint is reached again, and this method, the breakpoint is executed, and I end up with my PDB, and I can do that as many times as I want, unless I catch an error message, like here. My type error reared his ugly head again, because I removed the string casting here. So let's move the breakpoint up here a little. Oops, why did I type C? Whatever that does. Okay, now I'm in this method. So you can move your breakpoints around if you want, and you can say next, next, and you see it's going through this logic, and it's doing this. Value is now 7, and I can even execute my own code here, and I can even execute parts of this code. I can say 7 in value, for example, 7, oops, in value, and I get the original error. The argument of type int is not iterable. Or even worse, I can do this, and so now I fixed the right part of this equation if 7 is in value, but I broke the left part because in string, where value is a string, requires string as left operand. And we could actually experiment with that. 4 in 14, does that work? No, it doesn't work at all because it's not iterable. So if we do 4 in 14, that's iterable, false. But if we do 4 in 14, 4. So you can really play around, and that's what you're going to do a lot, because when you do, I call that PDB-driven debugging development, because you have an error, you manage to get a PDB in the right place, a traceback and a breakpoint in the right place, and now you can try to find the correct code that actually works. That is like 7 in value. This is what I'm looking for. And then you just copy and paste the correct solution and use that in your code. This is, I do that all the time. Like I write the correct code in my PDB and paste it into my application, and then it works. Not all the time, but more often than not. So, okay, let's go a bit faster now. So this was next and continue. Let's look at args that prints the arguments list of the current function. So I was always inspecting value here, but my method is unlucky number. Okay, let's step in this method first. So now my debugger is in unlucky number, and I could inspect value, but I could also say args, and I get all the arguments and their names that are passed to this function. This is especially interesting when your function is really long, when you get a lot of arguments and they're complex and you need to inspect them and you don't want to look at them individually. Just say A and you got it. That's all you need. And you see all the arguments that are passed to the method that you're just looking at. So I also did something else. I'm starting this over and over again. So now I'm doing the next line of code that's executed is for value in values. So this is nothing that works like this. This doesn't make sense. You need to. I could actually do that value. So in a PDB, you can't do multi-line, but this works. So you can't do this and then indent. There is a way to fix that. I'll show you, but you just can't. But what I want to do is find out what happens in is unlucky number. But if I say next, it's already gone. So is unlucky number is already executed. So let's try this again. This time the step command, like in JavaScript, it's exactly the same. Or in the browser, you have the same user interface basically, but just with arrows. You point and click. You step into this function. So the function that is called is unlucky number, and when you say step, your PDB goes with you. It takes you. You go with your PDB inside this method, and now you're in is unlucky number, and your args are now the arguments of this method. So you can step into methods, and you can also step out of methods by using R or return, and then it goes to the end of this method, to the return statement. Well, in this case, the return statement is also the first statement in this method, so there's not a big difference. But if something else would be happening here, the R or return would jump me to this line of code instantly, and it could skip everything else. That's very useful. So this is next, step into, arguments, continue, return, and I very rarely use P or print. P, I mean, it's not print, because I can see p-value, and that's the same as print value. Actually, it's not. See? So here it's, you see that it's a string, and here Python ignores these the brackets. So, but it's the same as just saying value. So that's why I never use that. But what is very useful is pp. So for value, this is not interesting, but if I go, where am I now? I'm in unlucky numbers, so I do next, and it goes out here, and I'm back in my here, and I have values, so I can say values. But imagine values being something bigger. I can use pretty print to print my values, or if I have a really tiny screen. Why doesn't it work? It should. Okay. Yeah, we'll see that later where it's really useful, especially with dictionaries, because they're nicely formatted with pretty print then. So these are the most important ones. And before we go into any deeper into PDB, we'll install a improvement to that. Because I never use PDB, I always use Pdb Plus Plus. And you'll install that, and then you play around with it during the break. You're not allowed to get some coffee. No, sure. We'll do a 5-minute break. I'll get some coffee. You get some coffee, and you can play around with Pdb Plus Plus. There's a couple of alternatives to PDB. There's iPDB, which I used to use a lot. It is comes from the IPython notebook, which is now Jupyter, and it's really useful, but it has some weird dependencies which I don't like, and it's a bit too big from my point of view. There are a couple of PDB enhancements that have a user interface, like PUDB. There's a it actually, I used it for a while, but it's, yeah, I don't know. It's cool. Check it out. It really depends on how you work, how you like your terminal, which editor you like, and stuff like that. So I'm not going to judge. PUDB is really powerful. There's also WDB, which is interesting. I got that to run. It's a browser-based application. It's running on Tornado, which is an interesting async framework, and you can run your application through the debug your locally running Python instance in a browser debugger, which is kind of weird, but it works really nicely as well. So you can try that out as well. And there are a couple more. But my recommendation, and that's what we're going to do for this tutorial, is use Pdb Plus Plus. The good thing about Pdb Plus Plus, it's a drop-in replacement. It's on PyPy, and you just install it in your virtual environment, or maybe even in your system Python. I don't see why not, but I use a virtual environment here, so I'm going to use pip install Pdb pp, because plus plus is not a valid Python identifier. So pp, and there it is. And now when I run my script, I'm already in Pdb plus plus. And the most obvious difference is instantly visible when I do LL, because it is unreadable, at least for you now, because it's dark green and dark red. So it's super useful because and dark blue, which is the worst. But it uses syntax highlighting, and that's just great because, as I said in the beginning, code is meant to be read, not written. And syntax highlighting helps a lot reading this code. So with this, we're going to go into a short break, and you can play around with Pdb Plus Plus. Try to use exactly the same commands as you used in PDB, and just try to jump around in the application, inspect the variables that there are, and so on. And then we'll go into the advanced features and make sure your Plone and your Flask applications are installed, because I actually really want to spend some time in these as well. Okay, if you have questions, put them in the Slack, and I'll see you in 5 minutes. Okay, let's go. So Pdb Plus Plus. Pdb Plus Plus is awesome. It's free. It's a drop-in replacement. Needs no configuration. It has syntax highlighting. It has tab completion. I also have tab completion in my Pdb, but maybe that's because of my Z shell. I'm not sure. Or maybe it's included in a newer version of Python. I don't think so. It must be something in my setup. Pdb Plus Plus is also available for Python 2, and it has these same commands, and the most important one, again, being LL, which is not available in Pdb in Python 2. So if you still have to mess around with Python 2 applications, which I sometimes have to, Pdb Plus Plus is great because it gives you syntax highlighting and LL. Everything else is even more exciting. Advanced introspection, we'll get to that, but LL in Python 2 is already, I would pay money for that if it wasn't for free. Okay, this is, so if you say Pdb Plus Plus help, it gives you a couple more commands, and we'll get to these. So, but first, we'll check out the advanced things that are going on here, and we'll still use the old, the Python script that we have here, and see what we can do to mess around with that and learn these additional commands. So I installed my Pdb Plus Plus, which means now I get my syntax highlighted code. I maybe should change my color scheme to something more readable. No idea how to do that. Is it okay? I think it's readable enough. Just it's not that long, the code. It's okay, Andre. So if you say so, yeah. It's for presentations you shouldn't use dark mode, especially when you're using a projector. On Zoom, it's basically okay because people usually have laptops and screens and they have good lighting. But on a projector, this won't do. Nobody would be able to read anything. So okay, Pdb Plus Plus. So to make make use of all these advanced features, we have to understand how a Python application works. And it's what you need to know is the stack. And it's not a stack of cards where that's also a data model where you, in some languages it exists as a built-in, it's like a list where you can only add stuff on the top basically and take it out, like a, yeah, whatever. So in Python, the stack is a list of stack frames, and each stack is a function call. So here is the print of a stack, and we could do the same here with the where command. It tells you where you are in your stack, and you already see there's a tiny difference between these commands, because but why? No, because yeah, I have to go, hang on, I have to go in here. Now I have the exact same stack because I moved my breakpoint here. Let's move it here so it looks exactly the same as in the presentation. So where in the Python stack am I? So this is my stack, and it shows you each stack is, as I said, the execution of a method, and since this method is called by that method, and that method is called by this statement here, and this statement is then called by my Python debugging PY. This is like how they are layered on top. And the cool thing about that is, like we did before, we could just follow the flow of the application, but we could also jump around in this stack, not only going step into something, but we can also say, okay, I'm here now, and this method is unlucky number was called here. How can I go from here to here? Let's just take the elevator, and the command is up. And it says, I go up in my stack. If I say where, the arrow, it's a small arrow here in this here where my mouse is pointing, and it points to the nested loop statement. If is unlucky unlucky number, sorry. So I moved up in the stack to a different frame. And now if I do LL, I'm in this code, even though the code that I was actually, when I started was this, and the value, it's like a time machine. I went to the previous, the method that called the method that was in, even when I was way down there. So I could actually go say next, and it's executing this is an unlucky number line, going to the next one, print, where am I now? Here, print value. So it executed this number, and I'm here. And I can say up or U again, and I can go up once more. And I'm here in my if here, name equals main hook that starts the whole thing. So I can move up and also can move down again, and I can inspect where I am, and I go up and I go inspect it again, and so on and so forth. So I can jump around in this application with the where statement. It shows me where I am, so I don't have to ask for help anymore because I already know the commands. I can ask now the inhabitants of my Python application where I actually am. I can ask it to go up in the stack and down in the stack. There's a couple more interesting things that I'm going to show here. Is the display command. Let me use that here. Moving this here, let's say, and I'll. So if I say display value, it doesn't say anything now because value doesn't exist yet. So if I say next, so I execute the next line of code, it tells me that value changed from undefined to 14. Okay, next, oops, that was obviously wrong. Here again. If I say next again, executing the next line of code, just like that's the print statement for value in values. And now you see value changed. So I added a listener, a subscriber basically, to the value variable, and every time it changed, it tells me what it was before and what it is now. So that's very useful if you have long if you have a lot of data and you want to see what's happening. Why is this? When is this variable changing? You can step through the code and follow the flow and see. Oh, it suddenly changed because of whatever, something happened in the line that I just executed. Might not be obvious because if you have class-based and multi-inheritance applications, just self whatever could change for a reason that is not obvious if you're looking at the code. But if you see that it changes, and that definitely can help you pinpoint the cause of an error. Continue. And oh, I get this. We still have this interesting error. Actually, we haven't fixed our script yet, so it doesn't follow. It doesn't compute completely. We'll get to that. How do we get to that the easiest way? Yeah. Maybe not. Yeah. Maybe not. Not yet. Okay, let me print. Done. So, okay, first, let's fix this error, because we have to figure out what's going wrong. At some point, and we don't know what value is where before the error appears, our application fails. So luckily we have this printing thingy here that tells us it's either skipping something or it's using something. So it's not 14 and it's not 700. So it must be the one after that. It must be the 7. So if we wouldn't know that, we could also add again a print statement before the line where the error is happening. So the line is the error is happening in where do we have that here? It doesn't show me the line. Why not? Print value. Oh, print value in line 10. Yeah. So line 10. No, it's not right. It's just not right. It's not, the error is not happening in line 10. The error is happening. That's interesting. Why it doesn't it? Because the error is obviously here in line 8, but it is not showing me where the error is happening. It doesn't show me the correct line. Can anyone tell me why that is? Currently I have no idea. Let me execute that again. Oh, yeah, must be, I don't know, something with saving, I didn't say. So here, print skipping plus value can only concatenate. So now it's line 8. Maybe some caching going on there. I'm not sure. I'm not 100% sure at the moment. So here, skipping plus value. So what you is, since I know it needs to be, the problem is 7, I could just, and I do that very often, is do this. If value equals 7, breakpoint. So this is a conditional breakpoint done manually, and it's super useful if you have to deal with a lot of code. For example, I imported this huge amount of data in this application, but one item failed, and the error appeared after the failure, like after the import failed. So I had to figure out what it is and then add the PDB at the right place before the code that is broken is actually executed. Because going back in time is impossible. Is it? Question mark. Actually, it's not, but I'm getting to that. So here, this is like the easy version. The how does, for example, the easy New York teenage PDB debug version with a conditional breakpoint, and I can inspect my value and I see that it's this, and I can just execute the line of code that I know that's going to fail because I already saw this traceback, and I can see what's going on here. I can't concatenate a string with a not string because it's not int. What's going wrong there here? And it's exactly the same as the issue before. It is my integer is not automatically translated into a string. So why is that? Because I use this plus statement. So what can I do instead? I could just use, for example, this here. And I will certainly not get an error message now, because f strings and format automatically do string casting for the values that are injected. This has sometimes unintended consequences if you're logging an object that has a weird str method. So value str So Python has all these magic dunder methods that that are used for example, if you do string value, it's not always just taking the value and making a string of it. It's calling this string method. So if value would be a object, and the dunder string method would, if this object represented some code in your system, it will probably render the whole code. That's a terrible idea, because then string value would be a huge chunk of data that you don't want to be want to have printed just for finding out something. So it's proceed with caution if you're printing data, because even if you look at value and it's a string, that's, yeah, or an integer is obvious, but if it's an object in a complex application, it can be something really, really big. Yeah, just a word of warning here. Okay, I fixed that, and now my script should actually run through. Yay, it's done. 14, whatever. These unlucky numbers, we're not going to deal with these, and now we're done. So I wanted to show all of these, but we'll jump into the Flask application to do that. So, okay, it's Flask time. Flask is a micro framework. Let's close all of this. And here's my, I'm gonna not gonna remove this. So here, here's a very simple Flask application. You installed it by installing the requirements. It installs Flask and the requests library, each of which have additional dependencies. I'm not going to pin them, so kind of lazy. Not pinning requirements is a bad idea, but still. And it's really, really simple. It doesn't do a lot. It gets some stuff. Let's just run it and see what happens. So the README. Oops, hang on. Where is the read? Here, the README says, I run it with env flask app equals demo py flask run. So env flask sets the variable flask app to demo py, and otherwise it wouldn't find anything to execute. And it's already running in production mode. Terrible idea, but still, it's intentionally. It's not by mistake. So Flask by default runs on port 5000. And if I call the port 5000, I end up in my Pdb Plus Plus. Why do I end up in my Pdb Plus Plus? I end up there because, hang on, because I already installed Pdb Plus Plus. You should do the same. Pip list shows me everything that is installed, and one of these items is Pdb Plus Plus. So if you haven't done that yet, here also just say pip install Pdb Plus Plus, bang, and then run the application. So you get, you're never gonna develop without Pdb Plus Plus ever again, unless you have to log into a server where you're not allowed to install anything. But in a virtual environment, you can still. Thank you, Caleb.
Yeah, okay, perfect. Thanks.
Excellent. So again, okay, I'll modify my code just a tiny bit and remove the breakpoint and stop my application and run it again. So you see what's happening when you run it. It says, Chuck Norris destroyed the periodic table because Chuck Norris only recognizes the element of surprise. These jokes are so dumb. Fun. Still. So what does it do? let's look at that first. So data gets data from the method random joke. Random joke gets data from a external API. It loads this data and it returns this data. So the application is flawless. It works as intended, but I'll just create an error here, and let's see what happens then. So Flask is not executing this code because it's not a script. It's only executing this code when I run it. So and I get an internal server error. So that's a really bad idea. So what's happening here? I don't get a PDB, I get nothing, but I get type error list indices must be integers or slice, not string. Oh God, what's going wrong here? So, and now it's your job to use the tools that you already learned to fix that and figure out what's wrong with this application. So, and the first thing again is reading the traceback, and it's a good thing to not read it like this because that's not helpful, but read it like this. Just make it, maybe even copy it to an editor. Sublime Text has this beautiful distraction-free mode, and it's like it's invented for staring at tracebacks and not be distracted by ongoing Zoom calls or such. So let's look at it and see what's going on. So type error usually means that the code you're running is trying to do something with a data object that it's not intended for. So the type is wrong. Traceback focus, yes. Yeah, why not? You can use Pdb Plus Plus in a Docker container since it's just a dependency, it's a drop-in replacement, and you don't want to do a PDB in production anyway. There's no reason why you shouldn't do that. That being said, I don't develop with Docker a lot, so if you call if you have no way of SSH logging into your Docker container and actually looking at the running instance and getting a traceback from your running Python application, for example, because it's running in production mode for Plone, for example, and it just throws these errors in the browser, then you need remote debugging features for so your editor, for example, PyCharm has support for that, and you should talk to oh, help me out here. He's giving a talk. Again?
JetBrains?
JetBrains, yeah, JetBrains, but oh God. Talking ruins my brain, sorry. Yeah, there's Mr. JetBrains, yeah, not Mr. JetBrains. Paul Everett, talk to Paul Everett. He's giving a presentation here. He's a community organizer for JetBrains and development and evangelist. And he can tell you about the remote debugging features of JetBrains, where it allows you to have a application, your local PyCharm running on your local machine, but the application is running on some server, and they connect with each other. So yeah, good. Type error, list indices. So the index of the list. This must be a list, and this must be an index, but it obviously is not, because this. My code assumes that data is a dictionary and joke is a key in the dictionary. So this is a hint The data is actually not a dictionary because it's trying to use dictionary access, but it tries to interpret my key as a index, and they must be integers or slices, not strings. So data is obviously something else. So how do we oops, good, how do we fix that problem? So my Flask application is running. I don't have a PDB in here yet. I can just inspect this line. Just add my breakpoint here because hang on, where? No, not here. Here. And maybe I added at the beginning here where it actually was. So I'll restart that because I'm not running in debug mode yet. Trigger it, and I walk through my application. So now I can go into, say, okay, what's that? Data is, did I fix my code? That's terrible. No, it's not. Hang on. This is still broken. Why is it working now? Perfect example of debugging the debugging. So as I said, I can execute random joke. Okay. So I'm trying to get one joke, but what I'm getting instead is, so I always use m for my variable, then m. I get all the jokes because there's a typo. So when I execute this this line of code, data joke doesn't work because type data is a list and not a dictionary. So there is an error. The problem is I intended to create a different error and not this error, but it's an interesting error nevertheless. So I already executed random joke. I want to do something weird now. I want to go back in time and see what happens when random joke is executed. So how do I do that? I could just stop my application, run it again, and step into random joke whenever the time is appropriate. When I think it's I'm there, when I walk there with using next and step. This is one approach, but imagine this API would be more like Google Maps, where it says, okay, you can have 500 whatever, but after that you're out, or you have to pay with your credit card information, please. So I don't want to call this API 500 times until I figure out my error, because my error is obviously I get all the data, and especially Google wouldn't appreciate me trying to pull data from their APIs. Everything like data scraping, Google, they scrape. We don't scrape them. They scrape us. So what else can I do? I could do one of two things, and the first thing I could do, and that's the crap, that was good. I'll go back to until, because that's very important. But now I'm going to use jump. Jump, this is a J. For some reason, it's not readable. It's a J for jump, and it sets the next line that will be executed. And if I say jump, and I say this line, 11, my code, my current state, my kids are making a ruckus. The arrow, you see, the arrow moved from line 12 to line 11. So using the jump statement in PDB, you can actually go back in time, because you pressed N a couple of times, and oh crap, too late. I pressed N1 too many times, and this crazy line of code was already executed. So, but I have to start all over again. And now I can use jump. I can use step to jump into random joke again, inspect my code here, and then see what's going on here. The problem is my my error is bad, so I'll have to actually, whatever. I'll change my error. I hope. I hope this creates a better error. Let's see. Oops. Oops. It's also 200. That's terrible. Yeah, much better. Okay, let's make a typo here. And restart my application. Do the same thing again. Run the code. And okay, step over that. And I already get, oh crap, what's gone wrong here? Max retries exceeded with URL. So there is something wrong. Either they didn't allow me because my retries exceeded with the URL, I didn't pay up enough money and stuff like that. But I'm already like, I can't step into that anymore. It's already executed. I could jump to line 10. Now I can't jump anymore because I already, I blew that. That's a really terrible example I'm using right now. Okay, let's do, yeah, whatever. Doesn't really matter. The point is you can jump. Now it works, and I don't get a Pdb breakpoint here. And okay, now since it's getting annoying, it's getting annoying. It's even getting annoying for me, and I planned for this to get annoying. I'm using an application, and I have to restart all over again because I changed one line, and I have to reload my application, and I don't get tracebacks and stuff like that. It's just super annoying. So whenever you use an application, it is really good, and you have to spend more than 2 hours with that. It is really good time invested to learn about the debugging features that are built into that application, the support that not Python only, but the application gives you. And for Flask, I hope I documented that in the README here. You can run Flask in debug mode, and it's on the front page of the Flask documentation. And if you say Flask env equals development, you get two really nice features that we were missing out now. So now it says, okay, it's a development environment, debug mode is on, debugger is active. There's even a browser debugger thingy. So let's go into our code, just execute this application. Now I'm in my Pdb. I continue. I get my report, my results. Everything is fine. And now I create an error. Oops. Here my O. Change my O. Remove the breakpoint. So what you didn't see is it detected a change in the code and reloaded the code. So it auto-reloaded the whole application for you just because you changed a file. And that is super useful if you're doing Flask development. So when I execute my code now, the new code is run, and I don't get I get a traceback here. So I get the same traceback here that I got before, like my connection pool max retries exceeded with URL. The whole thing doesn't work. And I also get this information in my browser, and I can inspect the stack trace in the browser. And I can even, and that's like an advanced Flask feature, I can even inspect a stack. Here is my code data random joke. I could inspect the local variables here when I click on the code. It shows me the code, and I can click here, and it gives me a terminal. And if I add the pin that I have here, I could debug in the browser. So if you're using here's my console now. I can say whatever. What can I say? Demo is the function demo, and I can't. This is not a PDB. I can't use LL or something like that. It tells me this doesn't work. But applications like Flask give you these amazing debugging features where you have an error, and you don't even have to leave your browser when you have an error. When you're an administrator, you just enter your password, and then you can say inspect whatever you have here, and you can see the code. You can execute this random joke thingy and pass foo, for example, and see that it doesn't like a argument being given, and so on and so forth. So that is super useful when you're doing that. But what I actually wanted to show you is the jump feature again, to put that bring that home. And I just can't think of a better way than just do that right now like this. I reloaded the code. I didn't add an error. I didn't add an error exactly. I'm executing the code now, and I get my PDB. Still, I can mix these two. Like I get the debugger of Flask, and I get my PDB here because I use my breakpoint, and I can. Oh, I have 2 breakpoints. That is one too many. So here's my next breakpoint. Now I'm here, and this line of code, I want to go there, jump to 11, and step in. And so what I actually wanted to show is ruin the URL, because when you get a joke is a response object from the requests library, and you should always make sure that you always do that. Joke raise for status whenever you use the request library, because the status in this case is a 200, which is fine. But if there is a error in your data source, then it will return a different error message. And if you don't raise the error status here, you'll think you made a mistake, where the fact is that the application that you're using to get your data from is actually has a error probably. So that's always do this raise for status, and it doesn't do anything. It's a no op if there is no error. And then you can actually load the joke text. So that is what I wanted to have, is joke text not being available, but interestingly, it failed even before that. So that was jump, but I could do something else, something even more fancy. Let's do that. So let's continue and reload and remove this breakpoint and reload again and call that. Why am I not in a PDB? Because joke is not defined. Excellent. So yeah, that would be a good thing. So joke is not defined, I get an error message here. I have here, name joke is not defined. I can inspect the code. I can even do that here. But there's something else that I could do, and you should know about that. I should have used that for the script. So here I have an error and can say, okay, joke is not defined, joke. And I obviously see, this doesn't exist, but response exists, and I can, why don't I see the output of that? I don't care. So the point, hang on, response text value. Now it should work. So when you have a application that is running, throwing an error at some point. So we have this, it works fine, and I did this small change, and now it broke because I forgot to assign use response with the same thing. I already assumed it was a joke, but it wasn't a joke. It was just a response from the API, and it could have been an error because the API is down for maintenance. There's nothing funny about that. So, so how do you look at the PDB, see where it happens. You can do a if value equals something, do a PDB, but you could also do something more interesting. You can run postmortem debugging. Postmortem means your application is not dying, but it's throwing an error. And whenever an error is thrown, you'll end up in a PDB. And you can do that. I'll jump ahead a little here because it makes way more sense to have that here. I'm not going to use the Flask debug mode for that because I'm not sure if it actually how they work together. I could just run my application, but there's no postmortem debugging like this. But if I say, oh fuck, this won't work. This will probably not work at all. Okay, I'll probably have to go back to my I'll have to go back to my script. Sorry about that. I haven't thought that part through because it should go way further. For Flask, there is probably, well, there is postmortem debugging because in development mode, you get this. This is your postmortem debugging for that. Let's make that a bit simpler. Go back to the script. And when you imagine again in your script, you have an error like the one we had at the very beginning, or the one that we had here. We could just say plus value. This was the second error that was there. Don't need the F here. And imagine this is a really long, tedious list, and I did this if value equals 7 thingy here, and I don't want to do that because it just takes too much time. It's annoying. This file is huge. It's somewhere in my file system. I don't want to change that. Just want to run this script using postmortem debugging, and instead of using Python debugging py, I say Python -m for module. Oops. Sorry, -m pdb -c, which is a command that helps you go through the first list of continues that you'd otherwise have to do. So always use -c continue here and trigger debugging. So run this script, and the instance, your script, even if it's running for 5 hours and it's doing crazy stuff, whenever there's a traceback happening, it doesn't show you, not only gives you the traceback that you can then stare at and investigate, it also gives you a real PDB. So run this script, and your script, I think you have a, how do you say? feedback loop. Okay, so now I got my, I'm in my PDB because I use postmortem debugging, and I can inspect the method, and it stops at this very instance that the error actually occurs. And that is incredibly useful if you have, the more complex your application becomes, the more useful this becomes. Because here it was easy to figure out, okay, after 700, there was a 7, and this line was actually the one that triggered this, and we could create a conditional breakpoint. There's various ways to do that, actually. But in this case, we just get our PDB here, and we can inspect our data and say, foo plus value will not work. Net, I'm gonna, no, I can't mute you, but you still have your audio on, so I'm hearing some feedback noise. So this is postmortem debugging, and that is what I actually wanted to show you when you how to get to that point, and I wanted to use that in Flask, but I obviously failed because I didn't prepare that part well enough. So let's go back out of that script, and so it's a bit annoying because you can press continue for a couple of times and nothing happens. So what you need to do is Control D to leave the application, and don't press it twice because then your terminal is closed and you'll lose all your progress that you can then copy and paste your code from. Don't get impatient with your terminal. Okay, let's go back to the Flask application, and yeah, where were we? No, actually, we should do the advanced. We should do this here first, the until. The until is also, a lot of people don't know about until. I'll go back to my script for a second again, debugging script. And I'm not going to use postmortem debugging, but I'm going to imagine this is a very, very long list of data that's coming in. And I have a breakpoint at some point in my application, and I'm gonna run that Python debugging, and I see that got values. That's gonna take some time, and I'm gonna have to do next and next and next and next and next, because what's actually interesting me is this line, because here's something interesting is happening. Actually, there's nothing interesting happening here, but imagine something interesting happening. So how do you get to this line? You could stop your application and put a breakpoint here, but we don't want to do that because it takes a while to start up, or you have external data sources that are dependent on you. So what you do is you say, okay, please, instead of pressing next 500 times, oh, I should fix that error, by the way. Again, I introduced that again. Oh, maybe I should introduce, no, shouldn't. I shouldn't introduce that here again. So when I want to jump, skip over a loop, there is no, I can't say break or continue, because if I say continue, it'll finish the application. It won't stop because there's no breakpoint anymore. And there's even if I'm in the loop, I can't say okay, break from the loop. That will not work for this in this case. So what I can do instead is you say until 11. and it will execute the whole application until it reaches that number, that line number. And you can even specify file names and numbers. So if you have a more complex application that goes through various methods, you can actually do that. And in Plone or other web applications, it's very useful to do that, because there can be long for-in loops, or when you're dealing with iterators, and they try. There's this infamous traverse method in Plone that actually tries to find the object that you're going to see in the browser eventually at some point, and it does a ton of things to find out what the data in your application, in your database is, that it will finally show. And to step through all these lines with next is just impossible. And using until line 957 is a lifesaver in this case. Okay. So this was until. Oh, and another one. Yeah, because I said before that in a PDB you can only do single line statements, like list comprehension, for example, I for I in values, and try to display that, or say int I in I for values, and see how that turns out, especially if your values can't be casted to an int, for example, whatever. So this is if you can't do for I in values, enter. This doesn't work. You can do this, print I, but this is terrible. It's not nice to read, but you can use interact. So interact opens an interactive interpreter with the global namespace that contains all names found in the current scope. That means that values and value are available here. And here you can write real, like, multi-line Python for I in values. Oops. And execute that. So this is very useful if you have to do conditional things here. For example, for I in values, and say if I is instance I integer. This would be really annoying and hard to read in a PDB one-line statement. Print type, yeah, whatever. It's an integer. It's a bit boring, my example here. And now it only prints the items that are actually integers. Or you can even use the up arrow keys. You just have to add write the whole code. You just can't. Oh, let's execute this the third line again. This won't work because it's a new statement each time. But yep. So here only print the strings, and this only prints the integers. So this is a really nice way to debug your code. You can exit the interactive console with Control D again. CTRL plus D, and then you're in your PDB again, and you can continue working with that. Okay, that was interact. We already did the jump thingy, but let's move into Plone. It's 6. Oh, it's already. Let's do a 5-minute break. But let's make sure. Sorry that the Flask thingy was not as as elaborate as I intended it to be. Let's move into the Plone thing. Can you give a show of hands how many people had Plone installed now and are able to do bin instance fg and have some thing except for a traceback statement that is coming out from that. So it'll start my PDB, and you already see there's a debug mode enabled because I added that, and it creates a cache for templates, and it's running on port 8080. And if you can see that, or even better, I'll delete that, hang on. If you can see that in English, probably, you're good to go. Can you, yes, 1, 2, no, okay. Yeah, you joined late, not a problem, Caleb, excellent. Cool, great, at least a couple of people have that. Get some more coffee or have a cigarette or a glass of whatever, and we'll meet in, let's make that really quick 5 minutes so we actually can finish the interesting features of PDB. Okay, see you in a sec. So, quick word about Plone. It's now running on, let's do that on localhost and not on 88.0.0.0.0, which is useful for in your local network if you have a Windows laptop and stuff like that. I always use localhost. So I create, this is the front page. I create a new Plone site. I'm going to switch to English because most of you people speak English, I guess, and not, where is my English here? I didn't know that you speak English in Rwanda. Okay, so you see there's plenty of languages. English, time zone is German. Click on Create Plone Site, and it'll run and it'll create a Plone site. I'm not going to go deep into Plone at all. It's a content management system. It's loaded with features, has default content that I'm going to delete. You can keep that content, never mind, just ignore that. You have a front page, maybe with content in it. We're not going to do any editing here. Or we could just say, okay, create a page and say here, whatever, something, foo, or blah, and you got your website going and you can publish and stuff. Normal content management things. Not going to do that. We're going to do some development with that, and your configuration that I gave you in that you have in the Plone folder contains a build out, which is a build tool for Plone that adds a couple of additional features. Similar to Flask, where we added the debug mode in with an environment variable and added Pdb Plus Plus using pip install Pdb pp. Here we also add more Python packages, but we didn't add Pdb Plus Plus in our PDB. We could have done so, but we added it as a dependency or a additional egg, Python egg package to Plone. So this uses Plone, Pdb Plus Plus, reload, so the code can be auto-reloaded, and Pdb debug mode, which is for postmortem debugging. And also a small Python package called Minimal. It's actually downloaded from GitHub. It's here on Strasbourg Minimal. It's a very minimal Python package, has a setup PY that declares 0 dependencies, and it has a view which is similar to our Flask, here our route, called demo. In Flask, we assigned that our demo method to the route of the main URL of our application. Here we configure our browser view, it's how it's called, with the route demo, because it says name equals demo. So if you call demo, you're calling the code that's in here in demo py. And this is the file that you want to look at. So if you want to follow this, it's in clone src minimal demo, because minimal is the folder that contains the Python module minimal. Or the Python package minimal, actually. It's a package with a module. Yeah. As I said, it's minimal. What does it do? Again, some more crazy jokes. The same jokes, actually. And it creates content from these jokes. And I'm just going to call that, I hope it works, it should work. Here's my site. I just click on the logo, get on the root, and if I say demo, it'll call the code that I written. And unless I made an error, oh, excellent, I made an error and typed, what did I type? Amounts, excellent. Where did I type that? Ah, God. Amount. I hope I didn't commit that to the package. So I changed my code, so I could use do the reload thing. But first, similar to the postmortem debugging, I already get my traceback. So that was actually unintended, but it happens all the time. You just type away on your keyboard, you get your tracebacks, you get your errors. And since I have a built-in postmortem debugging with Pdb debug mode, that's the package here, there's a couple of features, one of which is that whenever a traceback happens, I end up in my Pdb. If I say continue and I wouldn't have Pdb debug mode, I'd get my traceback here and I could restart my application and do that, the whole thing again. But since startup takes some time and the more complex your applications become, that the more time it takes to start it up, because it has to connect to various databases and stuff like that. So that can just take some time. I fixed my code, which was actually unintended, the fixing. I'm going to do the reload now. So I changed something here. It doesn't get auto reloaded because, yeah, because I don't want it to, but I can reload it by hand if I say reload code on add reload on the root. But that's not very important. More important are the Pdb tools that I'm going to show. So when I call this method, again, my framework gets me a Pdb, and I can inspect the code that's going on here. So I'm already in a traceback, so I can't do, I can't say, I can't jump here, but I can execute code. And here comes the next amazing feature of Pdb. That is the debug statement. So the interesting thing about the debug statement is that it's not documented, and even if you find out that it exists, you have no idea what it does. Say debug, entering recursive debugger. Okay. Help me. Where am I? List. I'm not getting any code. Return. What's happening here? Nothing. I have no clue what's happening here. So the way that the debug statement works is, in this case, is actually I broke it because I just called that. The way the debug statement works is that you pass it a callable. Say debug space, don't call, space, and let's say self-random jokes. And you pass it a callable and you call that. And then you press enter. And then you are nowhere. Say list, there's nothing. So the magic is now you're in, I'm not sure if you're familiar with the Bible, but there's a place called, there's a place before you go to hell, you're in purgator, and that's a Vorhölle. So you have to press step to actually get where you want to go. Now step, and then you instantiate, you call the random jokes method with the debug statement, and you actually stepped in it. It is similar to the jump statement, where you can jump into places, but you can execute it anywhere, and it doesn't have to be in any. It doesn't have to be anything that is connected to your to the current code that you're running. So now I'm in random jokes. I can execute random jokes, and I see, okay, here are my jokes. The response is that, and the jokes text is this, and I can read the value. That's what this code is doing. It loads jokes text value, and it goes next and next, and now next and next again, and next again. And that is why you don't do that very often, because it is sometimes super irritating to actually get out of that debug thing again. But let me show you an example where this is super, super useful. So imagine Plone is a system that deals with content, and I've been calling this method, this view, quite some times now, and I have no idea. Imagine I don't have access to my browser, because I could just look at my browser and see if there are any jokes there. But I want to inspect my database, my application that exists. And as I said before, my Pdb here is full-blown Python. I can do everything that I want. So I can say self context, and I can inspect the objects that I have in my code. So that gets us into introspection. But first, let's use the debug thingy once more to see where we are. There is a view. Hang on, where's that? I wanted to inspect that. View, the container. Yeah, the container. Self context. Exactly. That was that. Yeah. Exactly. The self context. Imagine you're inspecting this object that is used as a container for the content that you're creating from the JSON data that you got from the API, and you want to find out something that's going wrong on there. And there's this method called how's it called again? Hang on. It's called default view. Nope, that's not the one. Hang on. This is the wrong line. Where is my notes file? Hang on. Oh, here it is. Aha. I don't know why I didn't. I copied it into the wrong place, it seems.
Default under view or default under page?
No, it's view. It's view, actually. Yeah. There was a reason why I ended up in view for some, but I found out I can't find what that is anymore. So now let's inspect this stuff here that we have. So self context is the site, the Plone site, and it has a method called view, and we can see it's a bound method, and we're going to use a couple of features of Pdb to find out what would happen if we call that. So it returns, for some reason, if we call that, it returns some HTML. So super weird. How does that happen? The reason is that view is something. So how can we go in there? We could now say debug self-context view, step into that list, and then we can see what it actually does. Because we would have a hard time figuring that out otherwise. So PDB helps us execute any kind of code. So you, how can I, hang on. Why is that? This is, for some reason, I can't escape my interactive debugger anymore. Something is wrong with me, but never mind. So I'm going to do that again. Calling this method, ending up in my PDB. So self-context view is the method that I want to find out why it returns HTML. There was some reason why I wanted to do that. Can't figure it out. So I step into that. I can inspect that, and now I called some code. That's the whole point here. I called code that is not called in my code at all. I need to know why that happens, because I'm getting. I remember there was a reason with the default page, but never mind. So I need to figure out what's going on there if something happens, because this is executed somewhere and the result is unexpected. I want to follow these trails, these breadcrumbs, to figure out what actually is going wrong there. So I follow that and step into self. You saw I used S step, and I went into a method called call, because self is obviously call for some reason. That is weird, but it's just what happens. And then when I follow this, I get to self get layout, interesting, and I can inspect what layout is. And it's a listing view, interesting. I can follow that anymore. If layout is none, we get a value error. Okay, there it is not none. And now it does the self-unrestricted traverse. That's by the way the infamous method that I told you about. So if I step over that, I end up in a template that is then rendered with the data. It's like it's a templating language. It's called Chameleon. It's used by Pyramid and Plone. And if you know Jinja or Mako, it's not much different. I really like that language, layout language. Template language, sorry. So I figured out that container or self-context, that's the container that I'm creating content is, has a method called view that returns HTML, and my task was to figure out why that happens. And with the debug statement, I was able to follow these breadcrumbs and this information until I found this method that I'm in here that actually renders the template. When I can step into that again, that's another call method. And yeah, the rabbit hole is a bit deeper than you might want it to, but that's Plone for you. It's a pretty complex system. And in the end, it's rendering the template with the data that's attached to that object. So,
Philip, we have about 11 minutes until closing remarks will start.
All right. Oh, now I was able to leave my recursive debugger using exit. I forgot that, yeah. My muscle memory was there, but my real memory was not there. Or not. Yeah, I'm not in that code anymore. Maybe because of the traceback before. Okay, let's remove this and okay, let's try to bring home the most important points that are still missing. Let's add a breakpoint here. Start the application. I'll start the application again for simplicity's sake, and show the debug statement allows you to add to enter an interactive debugger of any code that you may have available. It doesn't have to be a line of code in one of the methods or even the application. You can import something from the standard library and jump into that code using the debug statement. Pdb, you can use jump into code of Pdb Plus Plus. It's a pretty small module, actually. There's a couple more things that are interesting. Okay, let's call this. So here, I have my application is running, and I can I had this view method or the API content create method. Let's say that's it's a function, and with Pdb Plus Plus or with Pdb Plus Plus, I can inspect this function using the source statement, and it prints me the source of the whole code. And I never use that. Why is that? Because there's a nice shortcut for that. It's question mark, question mark. You can inspect with a single question mark any object, and it gives you the signature and the parameters that it accepts. And with question mark, it also gives you the whole code for this method. The same could be done for, so if we step into our API content create method, and we have the self context here, which is the container again, and you remember the view method, I could just inspect it like this. I don't have to debug into that or jump into that method to look at that. I just ask Pdb Plus Plus to, hey, tell me what this is. It's a method, it's a bound method, and it has a doc string, and so on. And you can do the same for the self method. Oh, wow, excellent. Oh, that was not self, but it's rendering itself. Yeah, that makes sense because self is the call method, and then we're in the call method. That's why I didn't understand that before, because it's calling itself. So it has a call method, dunder call. It's a magic, one of these magic dunder methods. And so it's calling itself, and the call method then finds the template that's associated and renders that. But I'm still, unless I made a mistake, which I seem to have done here, I'm still in my in the code. That is, I haven't left my scope here, which is really, really useful to not leave that scope. Okay, how long do I have? Can I have 5? Do I have 5 more minutes?
Yeah, you're going to be buttoned right up against the end if anybody has questions.
Okay.
Don't forget we have closing remarks and virtual networking today, folks.
Okay. So another command useful is edit. Wasn't that obvious? Okay, let's close this file here, my editor. Whatever that is, go away. And also this, go away, please. Bam. So it opened my editor because I assigned a variable edit to Subble, which is Sublime. By default, it uses Vim. So even on if you're in a remote session on a server and you use Pdb Plus Plus, you say edit, it opens Vim, the method and the file that you're actually working on at the moment. So that is really useful. And the plus 30, I have no idea where that comes from. That seems to be something from edit. Okay, that was edit, inspect, debug, source, condition. We'll skip conditional breakpoints. We did postmortem debugging. Oh yeah, very important. There are a lot of built-ins. Okay, let's go through that. So here is I created a joke. That's the new content item that I created from the REST API. So I want to inspect that. I could look at that in the browser, but the transaction is not gone through that yet, so I can't look at it in the browser. But I want to inspect that. And most Python objects in most applications subscribe to the dict. The way they act like a dictionary to store their data. Even if they are not dictionaries. So this is not a dictionary, but it has a dict method underneath, and it allows you to inspect that. And so if you say joke, you all probably know dir, which gives you all the methods here, and you can say pretty print dir joke, and it gives you a lot of stuff that is totally useless because same as Django and other frameworks, Plon uses multi-inheritance, so your objects inherit a lot of methods that are of no interest to you at this moment. You just want to inspect this one item. So dict is way more interesting for you. Pretty print the dict, and it gives you everything that you can look at as that is stored as an attribute and accessible with the dict syntax. There is way more, and so when I say help, that's the PDB help. But did you know that when you say help in Python itself, there is a help system built into Python, and you can use that to inspect all kinds of objects. So here, joke is my joke object. I can inspect that. In this case, it is just a stupid convenience subclass for document portal type. But if I say class, I can inspect this object and the whole inheritance chain, all the callables, all the methods in their right method resolution order. So if you every time you're dealing with a complex system, Plone, Flask, well, my Flask application was super simple, but it grows on you. You need to find out what's actually what you're dealing with very often. And this built-in help method of Python is really useful to find out what actually is going wrong, what's going on there. It shows you all the methods that are available on all levels of inheritance and in which order they can be called and what their doc strings are. So here is another call method, and there is my default view method, and I can inspect that default method then and can find out what's going on there. And here I can use Pdb Plus Plus to do that. I don't need to use the Python built-in help. So that is the help is very, very important here. And the instances itself are not that introspectable. The classes are. So you usually inspect the class and not the instance. When you want to look at the method resolution order, when you want to look at the data, you definitely need to look at the instances themselves. Last but not least, the final word. Use pre-commit hooks to prevent PDBs ending up in your production database. There's a debug statements pre-commit hook, and you need to use Sentry. If you've never used Sentry, I'll show you why it is super important. And that's crap. Where's my links? Here's my link. Here's my memory error from earlier today. You see this is the memory error, and I can see the stack trace. I'm going really fast now, but the important thing here is okay, sorted. Yeah, so the stack trace contains a lot of information. This error is like 2 months old, and Sentry is a open source system that you can install that collects your stack traces, and not only in text form like this, and you can read that and ponder, but you can inspect each frame and look at and that's the magic of it, the local variables and the arguments that are passed to that. So here, retext got self-encoding and errors, and encoding and errors are actually here, and you can inspect that. You can see, oh, it got past the wrong data. It's an integer and not a string, or it's a string and not an integer, or it's none, and therefore you can't call decode on that, and so on. So that is if you don't use Sentry on your and the important thing is you can use that on production databases. So this was for development, this error, the memory error, but a couple other errors that I had in my links, they're not publicly available. Only I can access these. They happen in production environments, and I can inspect these tracebacks and see what was going wrong during the running application, and you see the error and the cause of the error even before your client calls you. It's Sentry IO. You can host it yourself or use Sentry IO. They have a really affordable services, and it runs on Python. And that's it, because we're running out of time. Thanks for your interest and for your time. And be sure to hit me up for questions in the Slack or at the social event, which is, I don't think, really in my time zone. But just drop me an email or something. And sorry for messing up the Flask part of that presentation. I'll have to work on that.